R has changed a lot. It's been about 10 years since it's been about 10 years since we've had this R meetup. As I mentioned earlier, we started as a small group, and we've grown. So I'm going to take a little bit of a retrospective between R, then, and now. I'm going to start with the community. And the community has changed quite a lot in this time. This was the very first meetup we held on April 2nd, 2009. Organized by Josh Reich, and there's 21 people who RSVP'd, probably far fewer who showed up. This was our 10th anniversary meetup. David Robinson live coded. We sold out in less than a week. We are now space constrained. That's the only thing really stopping us now is that we can't fit in all the people. Because you can see that graph there on the next slide. We can see we went from 21 members to almost 11,000 members, as I mentioned earlier. So that's a very big group. That's about 1,000 people a year. It's really, really grown. And our community has changed. The face of it's changed a little bit. This was us fitting in a small room for one of the very first meetups. There might be some of you here actually right now. And you'll see that we fit in a small room with lots of space between us. Well, fast forward to the conference which grew out of that, and there are many more of us in there. And because of this, though, we actually get to take some pretty epic selfies. Hey, he's right there. So we like to have a lot of fun. And the ecosystem for R has changed quite a lot as well in the past 10 years. The R packages. 10 years ago, we had about 2,000 packages. We now have over 16,000 on CRAN. So we have a lot to thank CRAN for doing this. There's a lot of people putting in their spare time. They put in a lot of effort for this. The way we used R has changed as well. This is what R used to look like. It was brutal. You entered code one line at a time and hope you didn't mess up, or you wrote it in a text editor and you copy and pasted. Thankfully, we have RStudio now, and it's so much easier. We have a text editor built in, we have an environments pane, we have files, we have so much going on, and obviously we need the dark background. Because no one in a coffee shop will know you're serious unless you have a dark background. And the prominent members behind the tools have changed. 10 years ago, Brian Ripley was probably the most prominent member and wrote most of the code in R. Today, that's Hadley Wickham. Things have changed quite a lot. So let's take a look at some old code and new code. How it was like then and now. Because it was so much harder back then. So as our first example, we're going to talk about calling multiple functions. It's a convoluted example, something you would never do this example, but just to give the point of calling one function into the next, into the next. So we will get the fourth row of a data frame using only the head and tail functions. Immediately, you're like, no, 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 don't do it. But it's just to show things. So we would write this. Call tail of head. And for head, you say n equals 4 to get the top 4 rows. Then of that, you're calling tail, which we did earlier, and take the last row. And that gets you the fourth row. You would never do this outside of bash, maybe. Well, yeah. And this is maybe the way programmers have coded traditionally, right? You would go inside and out. An Excel jockey would feel very comfortable here. But thankfully, we have Meg Ritter, however you're supposed to pronounce that. And you use the pipes. You say iris into head, n equals 4, into tail, n equals 1. The pipe has been so transformative. It just completely changes the way we work, the way we teach, everything. It's amazing. Working directories, dealing with paths, traditionally has been a bit of a pain. let's say you're in one folder for your Markdown document, and you want to go back 2 folders and then forward 1. So you'd go ///data. And then if you're doing it in one working directory, it gives you one thing. But if you're in a different working directory, it's a completely different experience. And then your homework doesn't build, and you're like, oh my god, I can't submit this. It's a pain. And I'm using it in conjunction of list.files to list all the files. And it only gives you the name of the files. It's not too friendly. Well, now we have the here package with the here function. And as long as you're in an RStudio project or have some other scaffolding, it will create the absolute path to that file or that directory for you, all dynamically. So you can code it one way in your laptop and hand it to someone else, and it works just fine on their laptop or their server or any other piece of equipment. And it's really, really nice. It's dynamic absolute paths. It's cross-computer, cross-user. It's very portable. And I combine that with the dir.ls function from the fs package to get the entire file name, the entire path, not just the file name. So let's read in some data. R could always read in data. We'll read in a CSV. For decades, you would use read.csv. You can see here we're using the old syntax for the path, ///data /pizza places sample.csv. You read it in, it works just fine, gives you back a data frame. OK? You can't see all the columns because it won't fit on my screen. It tries to print all the rows because it doesn't know any better. And you don't know what types each of the columns are. In fact, the text column name is a factor. It automatically got converted to a factor. I have spent hours being bugged by this because no one taught me strings as factors equals false. And if they did, there's probably a typo of all those s's. So luckily, we have readr and read_CSV, which I combine it with here to get the absolute path dynamically. It tells you the column types, and it has sensible defaults. So when you print it out, it only prints the first few rows, maybe the columns that fit. And it tells you the column types. And it doesn't convert strings to factors. It's still a character, unless you want it to be a factor, which saves you a lot of headaches. So let's talk about subsetting columns, getting a subset of your columns. Maybe the first time you used R, you tried the subset function. You would pass it a data frame, then the column names using non-standard evaluation a decade ago. And this can do both columns and rows. But there's a catch. If you ever read the help menu for subset, you can get unanticipated consequences. This is straight out of the help menu. At least they encourage you to use square brackets. So let's go ahead and use the square brackets. So if we take our data frame pizza base, square brackets, leave the first argument blank because it's the rows, give it the columns as quoted names. And it works. Works just fine, gets what we wanted. In fact, if you're using a Tibble, which is New Zealand for data frame, you can do the same exact thing. It gives you back your data frame or Tibble. But what happens if you only supply one column name? You get back a vector. No one taught me that. And I spent so much time taking my code. If you have 2 columns, great. You have 1 column, bad. So I had to transpose it twice to get it back to being the right orientation. But that turned into a matrix. I had to turn that back into a data frame. If someone just told me about drop equals false, A, why don't we know that? And B, why is the default true? So luckily with a Tibble, the default is false. You just give it a single column. No matter how many columns you give, you will get back a data frame, even if it's just 1 column. And if you want to drop it, you can do drop equals true, which makes a lot more sense. Or you could use dplyr and select your columns. You pipe your data frame into select, and you give your column names with no quotes, so it's easier to use interactively. And yes, if you give it just 1 column name, it gives you back a data frame of 1 column, as you would hope for. And if for some reason you wanted it to come back as a vector, you could use the pull function. And let's say you wanted to combine pipes and square brackets. You could by piping into a square bracket enclosed in backticks and treating it like a function. Because we can. So let's conditionally get rows based on some sort of logical condition. In base R, you would use square brackets. And the first argument, you would put in the vector you are doing the condition on. And if it's in the data frame, you do data frame $ column in your condition. Ugly. And it also keeps all the row numbers, the old row numbers. So 2, 3, 9, 11, 12. Notice it's out of order. With dplyr, you pipe it into filter. You give it your condition just as a column name. It's so much cleaner, so much easier to use. This is especially important if you have multiple conditions, like this case, where you say the price is greater than or equal to 3, and the city is New York. We have pizza base written 3 times. You're repeating yourself. It's kind of messy. So using filter, you list the data frame once, and then you give it the conditions. You can focus on the logic. If you want to get both rows and columns at the same time with one command, in base, you would use the first argument for rows, the second argument for columns, all in one command. With dplyr, each step is its own thing. You first filter, then you select. It's readable. Now let's see how plotting has changed in the past 10 years. Now, ggplot existed, but it wasn't dominant. People used lattice, or they used base. This is the diamonds data set doing a scatter plot. First, you have to specify the colors you want manually. Then you use the generic plot function with a formula. And you have to then, to set your colors, subset your vector using the column of the data frame. Then you need to add your own legend and remember where it goes and how to do it. I spent about 2 hours making this graph. Yeah. And it's not that pretty. Come along ggplot and look. Simple 1 line of code. I broke it up into 2 lines to make it readable. It's easy to see. You give it your aesthetics, and you tell you want points. Easy, done, totally flexible. Another plot that was very popular was a box plot. This was great when you had a pencil and paper. But the box represents the middle 50%, which means that thin line is 50% of your data. You're throwing away half of your data. With ggplot, I can make violin plots and overlay the original data behind it, color-coded by another variable. So you get a sense of the shape and density of your plot for what is just technically one long line of code. And that gives you so much more information than a box plot ever will. Send a histogram. This is a basic histogram you need to supply to vector. With ggplot, it's much more attractive. Then you can use highcharter to make it interactive. This slideshow is HTML. You can move your mouse over it when it's online. You can absolutely highlight things and have this be an interactive plot with that one little line of code. Time series plotting got a lot better, too. This is where if you use the base plot on a time series object, on a multiple time series object. But if you use autoplot from the forecast package, you get a much nicer ggplot, all automatically done for you, that one line. Much more attractive. And there are interactive packages like digraphs, which can help you also. Let's aggregate some data. Do a group by summary. Back in the day, we would use Aggregate, which is a great name for aggregating. But you give it a formula and a data frame, then the function, which is applied to the left-hand side of the data frame, and it's kind of slow. Thankfully, with dplyr, it's more SQL-like. You group by and you summarize. It's like SQL. It's really fast. And it will work on a data frame or a database or Spark. It's all the same interface automatically. If you want to aggregate on multiple outcome columns, with base, you need to C-bind the columns together, even though they're in a data frame. I don't know who came up with that, but it's not good UI. With dplyr, you only add it to the summarize statement. All you need to do is specify more calculations. So much better. Modeling has changed a lot, too. So much so that it became machine learning. And that changed a lot and became AI. So let's look at base R. If you wanted to fit a model, you would first create a formula, and I saved it to a variable for later use. And in this case, I'm taking a log of the outcome variable, I'm scaling caret x, y, and z, and I'm including my cut variable as a dummy, as a categorical. This is incredibly powerful. It won our Statistical Computing Award, but it's been overmatched by wide data. And it only really helps you with your training data. It doesn't help you with your new data. Thankfully, there's a great new package called Recipes, which lets you programmatically go step by step. Yes, it looks like more code, but it's more programmatic. You give it a simple formula with no transformations. You center and scale your numeric variables. You turn your categorical into dummies. You add an intercept. You take a log of your outcome. And then when you prep it, it does the calculations. It does the computations. When you're ready to use that on either your training or your test data, you either juice or bake. Yes, those are real function names. But it really helps you a lot. It works on both the training data and the test data. Let's go ahead and fit a model, a linear model. Base R you call LM. It's tested, it's easy, and it's actually very fast. It works really well. But it just fits LM. If you want a little bit of nostalgia, there's a new parsnip package based on a derivative of caret. And first you tell it you're doing linear regression. Then you set the engine. You tell it you're doing LM. And then you fit it based on the training data with a simple little formula at the end there. And this might seem like more code than calling LM. But let's say you don't want to use LM. You want to use Stan. You simply change the engine to Stan. If you want to use Spark because your data is already in a grid, you change it to Spark. If you want penalized regression, you change it to GlimNet. If you want to fit a linear neural network, you change it to Keras. Notice that it's all the same thing. You're just changing one line of code, one string in one line of code. How easy is that? It's really amazing, this package. And speaking of neural nets, they've been in R for decades. Brian Ripley and Bill Venables wrote the endnet function decades ago. Just like LM, it takes a formula and a data frame, and you tell it how many nodes are in your hidden layer. And it fits a neural network. It's only a one-layer neural network, so if you want to get a little more advanced, you use Keras. It's a lot more code, but it lets you capture more complex relationships. In this case, it's still a single layer. It's a dense layer, 64 units, and an outcome. You have to compile in place, which is not very R-like, but it works. You tell it how you're going to optimize your loss function, and then you actually fit the model. The way we get help changed a lot, too. You used to go to the R help list, where you might be greeted by things like, once you appreciate you have seriously misread the page, things become a lot easier, clearer. Let you guess who that is. And someone even responded to this with, hopefully this isn't in the manual, or I'm about to get shot. It wasn't nice. But thankfully, we have people like Mara answering questions on Twitter in a great, welcome, friendly manner. And people like attending this conference who are very welcoming and open to helping people out. So a lot has happened in 10 years since we've had the R meetup. And I'm thinking more towards my personal future, as I have welcomed a new R programmer. And those matching shirts were given to us by the Lander Analytics team and designed by Vivian Peng, who will be here tomorrow, because they're not just hex stickers. They're baby-themed hex stickers. Yeah, I love Tinyverse, Messy R, Burp R. It was a lot of fun seeing that shirt. It was one of the greatest gifts I ever got. So thank you very much.